All right, so this is C# day 3, and I guess we'll probably just go straight into it. We have, I would say, one more day C#, and then we'll go back to game development. So luckily this is pretty short introduction to coding, so I'm really just gonna speed through most of it. So if I am going too fast, please let me know. I will slow down, and if anyone has any questions, again, please let me know. Just unmute yourself and mention hey, I have a question. All right, let's just go into it. So table of contents. So for today, we're probably discussing math functions, if-else statements, and a switch case. So these three are the main topics for today. So numeric expressions. So most of the numeric expressions in C# are all items you've already seen before. They all still follow PEMDAS, so most of this should really be a review. We'll try a few of them in the editor as well, just to ensure that you all know this stuff. But here's the simple ones: addition, subtraction, multiplication, division. All stuff you probably already know: a plus b, a minus b, a times b, a divided by b. Notice that for multiplication we do use an asterisk. It's a keyboard. And for division we use a slash. All stuff you should probably already know. And then there's an important note for division, however. C# and many other programming languages, they have a different style of division due to the nature of data types. So if I did 10 divided by 4 normally, it'd come out to 2.5. But in C#, if I do 10 divided by 4, it comes out to 2. It's called truncation. Here, I'll show you this in action too.
Actually, this is kind of useful coming from Python, because sometimes you wanted to do that, but in Python to do that, you need to have another you need to get the math important and do the rounding thing. But in some of these languages, if you want to do it the other way, where you want the float, you just need to do a double slash.
I see I know I get what you're talking about. What Madhav is talking about is basically what in Python, this happens automatically. It will do the work for you and give out 2 points. So in order to get 2, you have to do more work. But as you can see, is everyone able to see the editor? I'm sharing my editor screen now. Okay, so I've written down console.writeLine 10 divided by 4 as an example. This read key is from earlier. If you remember that we have to put read key or else it won't stay. So if I click play, it'll show up, it'll run, and it shows up as 2, not 2.5. So that's something to remember. If I put, say, 1 divided by 4, we'll see what happens. Zero. Now, 1 divided by 4 obviously isn't 0. It's 0.25. But the reason this happens is because in code, the computer reads this as an integer and reads this as an integer as well, meaning it's going to compute the answer as an integer. So 1 divided by 4 is 0.25, but we need an integer answer, and since it's the closest integer is 0. However, even if you make it round up, so this should round up to 1 since it's 0.75. Oh, let me just close that and then run it again. It'll still print out 0. The reason for that is this is called truncation, or here, called truncation. Basically what truncation is that C# will immediately delete or cut off the decimal values past the whole number. This occurs only if the original two numbers are both integers. As a result, the answer is an integer. So if you try putting a float in instead, so you know how we have 3 divided by 4, if you do 3.0 divided by 4, in theory, it should print 0.75. Since at least one of them is not an integer and a float, the computer is going to take, okay, so this is a float, so it can have decimals. It's going to say, okay, that's divided by 4, but there's already a float in there, so this will probably also be a float. It'll just treat it as if it's a float. And the answer will become a float as well. So basically, if you're ever coding and you have to code some sort of mathematical function, you do have to be careful whenever you're just writing pure division, because
I think Python just treats everything as a float.
I think what Python does is that it automatically converts it. It does the work for you, basically. But most of the other languages like Java or C#, they won't have that built in. You kind of have to work your way around it, or just change one of your variables into a float. And so if I did x divided by 4, you get 0.75. Yep. But if I did yep, and then you get 0. So does that all make does that make sense to everyone?
Yep.
Got it. Yeah, that's the only weird thing about like division, or at least just normal operations in general. But once you get this down, everything else is just simple PEMDAS. Parentheses first, exponents. We'll get to exponents.
Where does modulus fit into PEMDAS?
I will talk about that too, actually. I actually forgot to include that in his presentation. But here, so here's the other operators, exponent and modulus. Now these will be a little new because there's not really a single way to do it. But the way we do it in C# and actually a few programming languages is you do a double asterisk. Basically what that says is a raised to the power of b. Now here's one that might be very new to most people is modulus. What modulus basically uses is a percent sign. What the percent sign says is the remainder of a divided by b. So what it basically does is, the way I like to think of it is we just do a divided by b. Whatever answer we get what's the remainder, and that remainder is our answer.
Oh, so modulus is like PEMDAS with a double M. Parentheses, exponentiation, multiplication, modulus, division, and subtraction.
Yeah, I believe it falls somewhere in between around the multiplication division part.
Yeah,
That's where it falls in like the rankings, at least for PEMDAS. But let's go ahead and try it. Console.writeLine. And then let's put 12 divided by 4. Now we know that's supposed to be 3, so just make sure. 3. But if we do modulus, now putting 12 modulus 4, so say for example, we'll do 12 divided by 4, that's 3, remainder 0. But since the remainder is 0, it's going to print out 0. There we go. So modulus here, say if we did, I don't know, I guess we did 13 divided by 2, or modulus 2. What that should do is just check, okay, so 13 divided by 2, that's 6 remainder 1. So the answer it's going to print out is just 1. And right there, just like that, it's 1. Now, modulus actually has a lot of really good uses, even though it looks kind of like arbitrary. For one, it's a really good way to immediately figure out if a number is even or odd. What you can do is, if you put a modulus 2, it's going to check if it's divisible by 2 if you think about it. It's going to find the remainder. If it's 1, it's odd. And if it's 0, it's even. So it automatically checks if any number, no matter how big or small it is, if it's even or odd. Instead of having, I guess you could also take like the last number and check if it's like, a 2, 4, 6, 8 or 0. But it's just an easier way. You don't have to worry about it. So
imagine if you want to find out, say, if a number is divisible by 174 for some reason. How big of a nightmare would that be without modulus?
Exactly. It's just too much. But like, even though it seems like a really niche thing, it works out pretty well in a lot of situations. If I did var x equals, I don't know, 100, for example. So you can replace x, whatever, like with whatever value. Say like you have some like really complicated function, and whatever like is going to print out some crazy number, but with that crazy number is an x. Well, we could just quickly just check if it's, oh right, we haven't introduced that yet. Okay, but what we can do is using modulus, and later we'll learn today an if statement, we can check if a number is even or odd by seeing if the output is a 1 or 0. But I'll just go and continue. Okay, so they're a bit new, but they're still not too complicated. Modulus may be a bit hard to understand, but just remember it only gets the remainder. So we already tried a few in the editor. And here's the comparison operators. Now all of this, again, it seems like a lot, but it's not really, because you know many of them already. Equal to is like it just checks if two items are equal to each other, and not equal to checks if they're not equal. Greater than, less than, you already know. And great, oh yeah, sorry.
The reason that equal to has to have two equals is because, like, if it's one, it just sets the variable.
Yes, that's correct.
So if x single equal sign 3, it's always gonna be true, right? Or is it just an error?
I'm pretty sure it's gonna come as an error rather, because it's gonna try to set it equal to 3, but if it doesn't fit in the context, then it won't work. It'll just pull out an error saying
Yeah.
like this isn't. So
I mean, to be fair, that's probably a much better situation, since if it didn't do that,
yeah, I can see where you're coming from. Yeah. So what comparison operators do is that they basically return a Boolean. Does anyone remember what a Boolean is?
is
Oh,
a true enough.
I couldn't quite catch that. What was that?
True or false.
Oh, okay, I guess. Yeah. Yeah, both of you said it correctly. Yeah, it's a true or false, essentially. Remember, a Boolean can only really have two values, true or false. And what each of these comparison operators do is that they'll return that value, true or false. It will check that statement and then immediately check if it's equal to or not, and then it'll set it up so that it returns the value true or false. Now you already know greater than or less than. You also already know greater than or equal to and less than or equal to. Just remember, whenever you're putting the values, you have to set an equal sign at the end, not at the beginning or anything. And an equal to has two equal signs, as Madhav explained. You cannot put one equal sign. If you remember previously, if you look at the editor, we'll have one equal sign for variables. See, if you put two equal sign here, that obviously won't work. You can see it trying to see, you can read it. It says there represents a Boolean true or false value. But we're not trying to use a Boolean there. We're trying to set the value of x to 100. So you can only use one there. I'm pretty sure this works, but you can go ahead and do it directly into console.writeLine. So if I did x equal to 100, let's see, it should print out. Yeah, it should print out true. As you can see, it's returned a Boolean value here, but we cannot put one single x, or maybe you can, but we'll see. I'm not sure what will happen. So it just prints out the value 100. Okay, so I know what's happening here too. So once we set the value,
Can you change the value of x in console.writeLine? Or
right here, yeah, so basically we're just reassigning that value. So if you set to 30, it should print out 30, I'm pretty sure. Yeah. So basically what C# is doing here is that, say we have var x equals 100, we've established a variable x, we've set it equal to 100, and then the console.writeLine x equals 30, we're basically redefining that variable. It's as if we did this, like that, and we just reset the value of x to be 30 instead of 100, and we're just displaying x. So as you can see, it's not returning a Boolean value anymore, which is really the main deal. We can also try var y equals that. Let's just, for example's sake, and then we can do x is greater than y. Now x is greater than y, so let's try false. Yeah. So it just checks, is x greater than y, it can check the values, and but clearly 100 is not less than 30, so it's going to return false. And like that, you can also do it equal to, so if you did like 100, and then that returns true, since it's equal to, but notice if they're both the same and you did less than or greater than, it will return false, because it does not strictly be within the guidelines. There's also not equal to, and then so if 100 is equal to 100, it'll return true, but this returns false since 100 is the same as 100. They're not different. Not equals to only returns true if they are different. So, I forgot to save. But yeah, okay, it still works. So it'll return true. Okay, so does everyone understand these types of comparison operators? I will take that as a yes. Okay. So comparison operators are used especially when operating with Booleans. They're used mostly to help provide for decision-making processes. And as you can already see, most of these are pretty self-explanatory. There's some other comparison operators as well. You have an and, or, not. So these are a bit more complicated. So let's go into detail.
Oh, okay. So and is like if you have two comparisons, they both have to be true, or is only one of them has to be true. It doesn't matter which one,
Oh,
and
sorry.
not means it has to be false. Am I right? Also, there's one more called XOR.
Yeah,
Which checks it.
XNOR. That's used more in. These are logic gates too, but that's used more in circuitry. I'm not sure if it's used too much in programming.
I
Unless you do know how to use it in programming, I could be wrong.
no, I never really used it, but like I know it exists.
Yeah, XNOR exists. What Madhav's talking about is there's so basically these comparison operators fall under a larger group called logic gates. Basically, they dictate logic of like true or false, essentially. And a lot of X values, like there's like sorry, yeah, they do like inverses. It's a little
No, no,
weird to
no.
explain.
XOR is basically checking if only like if given like two comparisons, if two like booleans, only one is true. If both are true, it outputs false. If one is true, it outputs true, and if both are false, it outputs false.
Mm, no,
That
yeah,
can just be done with other operators, though.
Yeah, same.
yeah, no, Madhav's right in that, and then that's also true that you could do it with other operators. Yeah, no, I was thinking of NOR, NAND, things that start with an N. Yeah, so logic gates have another set of groups, but we won't go into detail. But to sum it up briefly, if you attach the word X to the beginning of like NOR, so XNOR and XOR, that's two different ones, and that's a different group. There's also NAND, NOR, and those are also two different groups. But we don't need to know about that. We only need to worry about and, or, and not. A little confusing, but okay. So and essentially what it does is that it will return. It basically takes two booleans and it'll check both sides. And if both sides are true, it'll return true. If either side is false or both of them are false, it will return false. Or is a bit more like accepting. If only one side is true, then all of it's true, and not just inverts the response. So a little complicated, but I will show you. And, or, and not are used especially when trying to combine larger Boolean like constructs, you could even say, or like equations. So I guess I'll add a few more variables. So I don't have to actually. I think I can just do x is greater than or equal to y, and then if I do and, fine, yeah. And then it may be better also to set up parentheses just to ensure that they're all in their own category. And then we have x. I don't know. Let's see. Let's do y equals 20. Now, since x is greater than y, and that y is equal to 20, this should return true because and looks at both sides. If both sides are true, then the entire thing is true. Yes. However, if one side is false, so say if it's set equal to 30, now x is greater than or equal to y. That's true. But y isn't equal to 30. So that side's false. If you set that, the entire equation becomes false. Now our next one you see here is or. Now, or is more accepting, like I said earlier. This is a little weird on the keyboard. It's like a straight slash. You have to do two of them. It's I'm using a laptop, so it's under my backspace key. I'm not sure if it's a different location for everyone else. I do apologize for that. It's a kind of a weird keyboard key. But what or does is that it just checks if at least one of them is true, and if one of them is true, then the entire thing becomes true. If I run this, it's still true, even if this second statement is false. I can change it up. I can make this less than. Oh, okay. So in this case, both sides are false. So I said now the entire thing is false. But if I make this one side true, the entire thing becomes true. Now, the last thing you need to know is not. Now, not, what it does is just inverts a response. So, for example, let's just invert this. So this was originally false because 100 is not less than 20, but we inverted it. So instead of being false, it becomes true. Now it's true or true. Well, that works regardless. But if we change it to and, run it, the entire thing is true. But if we remove that, the entire thing becomes false. Since this side is already true, and this left side we just inverted, that's why the entire thing becomes true. It's a lot of true and false words just thrown in the middle there, but does everyone understand?
Yes, we do.
Yeah. Okay. Well, whoops. Great. Okay, moving on. All right. So if statements. So in C#, if statements are basically used to coordinate decisions. Here's the basic structure: if, condition, and we have code that goes in the middle. And the code inside will only run if the condition returns true.
Also,
Now,
quick question.
yes.
Is it... I've heard it's bad to use a lot of if statements, like, for more advanced projects.
You've heard what uses a lot of if statements?
No, I'm saying is it bad to use a lot of if statements, like, as you go into higher level?
Okay, so to be honest, how many if statements you use is mostly dependent on the project you're making.
Well,
It's not really
basically,
bad. I mean, the only reason someone would call it bad if you use a lot of if statements is if there's a way to make it easier. There's a way to not use that many, and it's not that hard to implement. That's the only reason they would call it bad. But if the situation, see, I'll show you another. I'll show everyone another method. It's called a switch case method. I'm pretty sure you might have heard of it already. But that's a method that you can use instead of if statements if you have a lot of similar decisions. I'll get into that later though. It's near the end. All right, so let's go ahead and try this out. I'll keep these two because we've been working with them for some time now. But as I mentioned earlier, here's the if statement. What an if statement does is it has a condition in the middle. Now, if this condition is met, this code in the middle of the brackets will be run. That's pretty much all there is to it. All these comparison operators we're just learning and operations, we can things that return booleans can be put inside the condition area. So remember when we were trying to check if let's say x is greater than 100? X is greater than y. Well, since that returns a boolean, we checked with console line. The command prompt gave us true. Since it gave us true or false, we can put it inside the condition bracket or condition parentheses. And now what the computer will do is say, if this is true, now that's obviously true, it'll run this code. So let's do console.writeLine, and then let's print out, I don't know, this code works. I don't know, something like that. And if you go and run this, we should get this code works. There we go. However, if this is false, which this was clearly is, 100 is not less than 20, and we click run, you will get absolutely nothing. Since nothing, the reason nothing's appearing is because computers skip this line. I guess we can also write at the end to show that it actually does work. It's not that it's just loading. Code is finished. Yeah, let's do that. And then now if you see, we get code is finished, but we don't get this code works. Since this condition was false, it skips it. If you make this true, Control S, apply, we get both. we get this code works, and we get code is finished. So it immediately went to the first one, and then it went, okay, since the condition is true, we'll allow this code to run, runs this code, and then moves on to outside of the code. So it's a little different from our original structure. The original structure is that it goes from top down. It doesn't, the computer reads every line, not ignoring anything. But with decisions, we're able to control what the computer reads and what it doesn't read, depending on the situation. It's pretty useful, sort of the basic structures, and we'll definitely use it a lot. Now, there's a little bit more to this, but oh yeah, this is where the comparison operators come into play. By setting up certain conditions, we can make specific pieces of code run the program. We just went ahead and tried the editor. And what if there are multiple decisions for one chain? We just use an if-else structure. So for this, an if condition, code, else, other code. So let's go ahead and try that. Well, I'll keep that at the end, just to show how it all works. What an else condition, or else structure basically does is it sort of cleans everything up. That's how I like to think about it. So if first the computer reads this condition, if it's true, run it. If else, just skip it. But no matter if it skips it, the else will take it then. So say console.write line, the code was skipped. If this is true, the else code will run. But if this is false, this line is skipped, the else code will run. So let's go ahead and try it. Oh, I forgot to close this. This code works, code is finished. As you can see, the else line was not run. The reason why, x is greater than y. That's true. But here's the thing, if we switch the tables here, we try running it again, you'll quickly notice that this code was skipped, code is finished. So, in my opinion, I like to think of else really as sort of damage control almost. It's used for exceptions, anything that comes like out of ordinary, anything that's like, say, like typing in like your username, you get an error. I think the else line should go last for anything. Like the else line might say like, whoops, you made an error, please try again or something. It's like the worst, like last case scenario. All your previous ones will go in if. So there is one more thing. I'm pretty sure I have it.
There's also else if.
Yes, I was about to go into that, but let me confirm if I have that. No. Okay, that's fine. I will talk about it myself. I'm pretty sure it's just else if. Let's do x is greater than y. Yeah, okay, I'm pretty sure this is how it is. Now, Madhav, I don't think elif, let's check. I might be wrong. Elif. Yeah, so elif doesn't really exist.
Elif works in some programming languages, maybe.
I think it only works in Python. I don't think it works anywhere else. But yeah. So in order to get even more decisions and to chain them together, we can use something called else if. We're basically just tacking on another if. And we can also tack on another else. That's fine as well. And then you can just change it. It's second console.write line. This code is else statement. All right, just simple words. But as you can see, by setting up this, we have a chain. The computer will check this. Is this true? Yes, run this code. Skip everything else. Is this not true? Okay, move on to the next one. Now, is this true? Well, yes, run this code, skip everything else. No? I'll go all the way down. Now you can actually chain a ton of these together. And then all the way at the end, you can have one else, which again, like I like to think about it, it's like damage control. Just in case, if everything fails, we have the else just to back us up. Okay. And I now can actually go back and discuss about having, what is this? The even odd deal with modulus. Now, what I was mentioning earlier is with modulus, you can do something where you can immediately check if a value is even or odd. So if you use modulus, if statement, hold on one second. Okay, so if you do an if statement, and then we do x mod 2 is equal to 1, we can do like that. And we can do the same thing. I mean, of course, it's a lot easier to type in an else, but you can do else if equals to 0. And then like that. And then, I mean, I don't really know what else could go here, but like that. But yeah, so basically just dissecting this, you can see here, if the x modulus 2, we see that's equal to 1, console.writeLine, what's going to happen is that it's going to check, okay, 100 divided by 2, that's 50, remainder 0. Okay, but it's not equal to 1, so that this condition becomes false. Skips this line. Goes to the next line. Else if x is modulus 2 is equal to 0. Well, 100 divided by 2, that's 50, remainder 0. Well, we have remainder 0, so that's true. So it's going to display this line of code. But, else is just damage control if anything else happens. So let's go and try it. Hopefully this works. I'm pretty sure I didn't make any. Yeah, the number, spelled number wrong, but the number 100 is even. Code is finished. Okay, there we go. And I guess what we can do is combine this with user input. If I remember correctly, make sure if I remember it. So dot read line, I think. And then we can do for z for the sake of it.
These inputs are easier here than in Java.
Oh, like scanner?
Yeah.
Yeah, that's quite a task. So let me make sure this is the correct way to do this. It does ask me for it, right? Okay, so if I type in like 12, click enter. Okay, yeah. So that's correct. Can I do int? That work? Okay. Yeah, I thought so. All right, that's fine. But by doing that, we can pretty much set up a way to like immediately we can type in whatever number we want, and we can check if it's equal to if it's even or odd. And now that we have decisions at our disposal, we can make a lot of more adjustments. Is there anything else I want to discuss here? Does anyone have any questions? No, is it? Yeah, never mind. Okay, I'm gonna guess since there's no questions, I'll probably continue. I think we only have one more thing to discuss today. Yeah, switch case. Okay, so there's one more decision-making tool that combines the if-else mechanic, but for even more situations. This is usually used when there's too many similar situations to go through. So you have switch expression, and then we have case X, then we have that code break, case Y, code break, and we have the default. I like to think that as, as a simple else as well. Let's go ahead and try it out. and I'll explain what break means, and I'll actually talk about something else to continue. But we'll probably go into that a tiny bit more detail next week. So basically, the way I do this is, how should I do this? We'll just try it out. It's switch x modulus 2. Modulus 2. Can I just, yeah, I thought so. You have case 1 equal to. Am I doing this correctly? Okay, I'm not sure why that's. Whoops. All right, hold on, guys. I'm not sure why that's creating an error. Try something else. I don't know. Let's see. X equals 100. Oh, okay. I forgot the break. That's why. Okay, so the way this works is that you have a setting expression, and then you have cases for whatever the answers could be. So case true, that's, case the answer results in true. Then we have, I don't know, console dot write line. The answer was true. We can also have another situation, say case false. I'll go and put break down just to be sure. Console dot write line. The answer was false. Okay, and then so that basically covers everything. All the possible scenarios. So we have true and false, and I guess we can also have a default. And then pretty sure this uses a break as well. And then we have console.writeLine. Somehow, well, I guess somehow your answer is different, I guess. Okay. So by using switch in case, we can chain a ton of similar answers or possible choices. Now, although I'm only really doing Booleans, I'm pretty sure you can have other types of values, but just for simplicity's sake, we can see that, we have case in case that the answer comes out to be true. We have console write line, the answer was true. In case that answer comes out to be false, the answer is false, and we have the default, which is an else statement. So it's similar structure, almost the same deal as the if, else, if, and else statements. The reason people use switch is this can look a little tedious and tiring to type out everything. And in case of areas where you have very, very similar answers, what you can do is you can use a switch case. Now, what the break does here is basically it immediately exits the code. We'll get into more depth when we talk about loops next week. But what break really does is that it just immediately exits an iteration, or it exits entirely. So it'll read this case true. So for this, in our case, it's true. It'll do this code, and once it sees break, it will ignore everything here that's up until this parenthesis, and it'll start reading code from there. So that's why we use break here. Was there reasons like this? Never mind, I guess. But there's another version of this, which is continue. I'm not going to go into depth in that on second thought. I'll just talk about that next week. But Yeah. So does anyone have any questions about the switch case method? Now, I don't know if this helps, Madhav, for like if you're using too many if statements. Since there are no questions. Oh, yeah. Anyone? Okay, well, yeah, I think that's a bit for pretty much quick overview. Was there any projects I wanted to do? Let me think. I think that's it. I don't think I had any projects for today. Yeah, okay. Yeah, I think that's all right. All right, guys, I think that'll be it for today's class. I think a little short, but that's fine. I definitely covered, yeah, everything I wanted to cover today. And I think next week should be the last class, and we'll go back to game time. Does anyone have any questions about anything, really? Yeah, anything? Anything at all? All right. Well, in that case, then yeah, you guys are pretty much free to go. That's all for today.